Hey class, this is lesson 521. In this lesson, we're going to learn how to multiply uh, bigger expressions together. To do that, we're gonna use geometric models to multiply them, and we're actually going to learn some new words here. That's why I can't really explain what the objective is so much because you won't even know what the words are. But in a second, I'll get back to that. Anyway, just thinking about what we did before, where we were using rectangular models to represent areas and expressions for those areas and to multiply them. Take a look at this one here. This is an expression that we had before, so if we can represent this expression two ways. We can represent it as the length times the width, which would just be m times quantity m plus 3. We could also represent it by the areas inside added together, and the square inside there is m squared, and the rectangle here is 3 by m, so represent that as 3m. So another way we could represent that area is m squared plus 3m. Well, in the new type of rectangle that we're going to extend the areas of both parts of a rectangle and think about what that area is. So here we have the length is m plus 3 more, and the height or the width is m plus 1 more. And if I do length times width or base times height, I get the expression the quantity m plus 3 times quantity m plus 1. Well, we can also think of that as all of these four areas added together. This area is m squared. This area here is 3 by m, so 3 times m. This area right here is 1 times m, or just m. And then this little piece right here is 1 by 3. 1 times 3 is 3. So I can also represent this expression as the four parts added together, m squared plus 3m plus m plus 3. And I can simplify part of that by combining like terms. I get m squared plus 4m plus 3. When we have an expression like this that has three terms, we call that expression a trinomial. And we're going to put that on the chart here. Trinomial is three terms added or subtracted. And that would be an example like the one we have right there, m squared plus 4m plus 3. And we have a binomial, tri meaning 3, a binomial, you could probably figure that out, means two terms added together. And that's what we have up here. That's a binomial there, that's a binomial there. So we're actually multiplying two binomials there, and that's our objective here, to learn how to do that. And in this case, we ended up with a trinomial as an answer when we wrote that in expanded form. So two terms, like m plus 3. And a monomial is just one term, and a term can be any combination of numbers and variables that only have multiplication. So multiplication only. That would be something like 3x squared. It's a monomial. So kind of focus on those terms so that when I say them, you understand. The key is that tri means 3 parts, bi means 2 parts, mono means 1 part. And if we have more than 3 parts, some of you are probably thinking, well, that must be a quadnomial. Actually, there's no name for a term that's longer than 3 parts. All of these and any other expression is called a polynomial. So, and poly means many. Can be 1 part, 2 part, 3 parts, or more. All right, so this is review. Express the area as a product and a sum, and we're going to use this idea a lot, so it's a good review. The product is what we get when we do length times width for the area. The sum is what we get when we add the 2 parts together. So this represents the sum, this represents the product. The product would be h times h plus 1 length times width. The sum would be the two parts added together. H times 1 is h, so h squared plus h. And those, since they both represent the area, they are equivalent to each other. So we're going to use that idea here. All right, to sketch the model of the area represented by the product x plus 2 times the quantity x plus 4. And actually, I'm going to go ahead and do that. So let's say this part right here is x plus 4 more. And then, so that length from there to there and that length from there to there is the same. That's a square. And then there's 2 more added on the bottom here. So one way I can represent that area is by multiplying the length times the width, x plus 2 times the quantity x plus 4. Another way I can find the area is by adding the 4 parts. This part here is x by x, so x squared. This part right here is 4 times this distance from here to here is x, so 4 times x right there. And then this little part right here is 4 here and 2 here. 4 times 2 is 8. And then that part there is 2 by x, so 2 times x. And so if I add all those parts together, I get x squared plus 4x plus 2x plus 8. And the 4x and the 2x are like terms, so we'll combine those to make a triangle here. That's what we're going to learn how to do. So some of you kind of have a little bit of an idea already what's going on, so we're good to go there. All right. So for number 1, we are going to sketch an area model to help find 3p times quantity 2p plus 4, just to make sure we know how to multiply something like that out. Some of you may already kind of know what the answer is, but we'll use an area model to show that. And so 3p, I'm just going to use this to show 1p. There's, let's say that's p. Then a length of 3p, I need 2 more of those. So I'm just going to clone that and do it one more time. And then I can attach those together. And I'll leave a little space so you can see the gap there. That I actually have 3 parts. So there's 3p. And that's the same as 3p. P plus p plus p. Okay. Now, 2p on the other dimension, I need the same length. I'm going to clone it and then just like that. So it's still, the length is still p. And I need 2p, so there I am, 2p. And that's going to be my dimension this way. And of course, I'm going to need that on the other end too, right? So I'm going to clone 2 more of them. Put them there. Like that. And then I'm going to need a couple more of these for the bottom dimension. Oh, that's right, we have to add 4. So I'm going to clone 1 more this way, because the side is 2p plus 4 more. So I'm going to shrink this down so I think it's about 4 inches long. And that's going to go right there. So now I have 2p plus 4. All right, and now I'm going to finish my drawing here. One more of those 4s. And then I'm going to, so this great big rectangle now is represented by 3p times quantity 2p plus 4, doing length times width. Now I'm going to show the inside areas using dotted lines here as dividers. So we can see what this is in expanded form. Okay. Now, each of these are squares, and they're all p by p, so we have a p squared there, 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 and there. And if I add p squared 6 times, that is the expression 6p squared plus Plus I have some little rectangles down here on the bottom. Remember this dimension is p, so if I multiply length times width on each of those, I get 4p for all of them. And if I add 4p plus 4p plus 4p, I get 12p. So we can see the expanded form of that expression is 6p squared plus 12p. And thinking about the distributive property, we would just multiply 3p times 2p. Well, 3 times 2 is 6, and p times p is p squared. And we're going to multiply 3p times 4. 3 times 4 is 12. And we have a p there times 1, which is just p. So we get 3p squared plus 12p. So what do you notice while multiplying a monomial with a variable p times another term with a variable p? We end up with a term that has a squared on it, p squared. So in this next example, if we do 2n times 5n, we have 2 times 5, which is 10. And we have n times n, which we write as n squared. All right? So determine the product of the following multiplication expressions. I'll just pick a couple to do. I'll do D right here. So we're going to take 3 times 2k. 3 times 2 is 6k. And then 3 times 3 is 9. So that's the expression we get there. And we'll do one more here. 2w times 2w. 2 times 2 is 4. W times w is w squared. All right. The other ones we can do in class. So, knowing how to break apart those expressions helps us do other things like divide and help us switch back from expanded form to factored form. Okay, and that's going to be the second part of this video. We're going to learn how to divide. I'm going to do one more problem here, though, right here. We want to write this as the product of a monomial, which means one term, and a binomial, which means 2 terms. So we're going to have something that looks like this, and I know there's going to be a plus there because there's a plus there. And I have to think of, well, what could be multiplied to get these 2 terms? And I notice a couple things. There's a d in both of those, so I could multiply something with a d in it. And I also notice there's that both those numbers are even, so both could be multiplied by 2. Both of those are multiples of 4, so that's the one I'm going to pick. I'm going to try and get the largest number that is a factor of both of those. And now I can just think of, well, 4 times what number equals 8? And that, of course, is 2. But there's a d squared, and I have a d here, so I need a d here to make a d squared. And then thinking about 12 divided by 4, that is 3. And 4 times 3 is 12d. So I can write it in factored form by thinking of a number that goes into both of those terms. And then figuring out what I need to multiply by to get that. All right, it's time to pause this, and we'll do the second part.